Good evening, everybody. I just need to wait and make sure that my live stream is live. Just waiting for YouTube to confirm that. Come on, YouTube. And yes, it is working. We are live. Let's get my slides up so I can see them. Good evening, everybody. Welcome to episode 10 of porting Gitflow to Golang live. And today on episode 10 we are bootstrapping the gal. Okay, let's put my camera on. Aha, there we are. Hello. Right, welcome to episode 10. We are a third of the way now through our allotted budget for this piece of work. And the weather has turned. So I've gone for a different picture this week. It's been very wet, very windy this last week or so. Welcome from Wales. What news? What news for Wales to this week? Well, we are halfway through our national lockdown, our COVID lockdown. We exit that a week today on Monday the 9th of November. While over the border in England, because they've delayed, they're about to go into a much longer, much more damaging lockdown. Their lockdown starts on bonfire night on November the 5th. Traditionally in the whole of the UK, we set off fireworks and burn effigies of Guy Fawkes to remember the gunpowder plot. And Guy Fawkes tried to blow up the Houses of Parliament. Well, no bonfire night this week for anybody really. So that's really one of the major news going on. While England goes into a lockdown with no end in sight, Wales comes out of lockdown next Monday. And from next Monday, our rules are actually different. We've been in local lockdown for a few weeks now before the national lockdown started. But from November the 9th, we will actually have our travel restrictions lifted. And for the first time in, I can't remember how long, we'll actually be able to leave the county and travel further afield if we wish to. However, it's still a good idea to avoid all human contact, given how prevalent cases are in the community right now. Best to be safe. Now, whether you're watching live or wherever you're watching from on catch up, I'd love to hear from you. Leave a message in the chat or leave a comment on the video if you're watching on catch up afterwards, and let us know where you're watching from. How did you find us? Tell us a bit about news in your part of the world. I'd love to hear more. One of the things that's helped Christy and me, my wife, get through lockdown in the last week or so is we've been watching documentaries, for lack of a better phrase, made by people in Japan, foreigners living abroad in Japan, and we've been doing tours of typical Japanese apartments and very non-typical ones and traditional housing, and also what it's like to live, work and travel in Japan, and we found that fascinating. So please do share with us your stories. Tell us about your part of the world. That'd be awesome. What's the plan for tonight? Well, tonight we've got one main topic. 2 weeks ago we were working on the init command and we made some good progress there. And I ended that live stream saying it felt like we needed to create the Git Abstraction Layer as some sort of construct that we initiated and then injected into the workspace and the repo, one way or another. So that's what we're going to do tonight. We're going to focus on getting the Git Abstraction Layer up and running and working. And then we're going to bootstrap that piece of code. And then we're going to figure out how to integrate it into the workspace abstraction. Excuse me, and how to integrate it into the repo abstraction, the local repo and the remote repo that we've been building. Who knows, I may even get the code to compile tonight. We'll see how we do. And just to recap, let me switch over to iPad cam. And hopefully my Apple Pencil is charged this week. So what we're talking about, let me bring the iPad to me so I don't disappear off camera. What we're talking about is this section here, the Git Abstraction Layer. And what I'm looking to do is to initialize this as its own data structure in its own right. The purpose of the Git Abstraction Layer is to hide Git from everything. I don't want our workspaces or our repos talking directly to Git. I want them to go through an abstraction layer because, let me just tidy that back up. We know for a fact that different versions of Git work in different ways. Let's go back to slide deck cam. We know that for a fact, and we want to be able to support multiple versions of Git sanely and safely, including a mock version of Git that we can use for testing when we get around to our testing. And so to do all of that, we want our Git abstraction layer to happen. So that's what we're going to be working on tonight. Now, in terms of time, I reckon I'm going to be streaming for about 2 hours in total tonight. And you should see that reflected in the length of the video if you're watching on catch up. That's the aim. We'll see how we do. All right, let's get into it. Let's switch over to Linux cam. Here we go. Here's Linux cam. Let me just tidy up my main display at the minute. Come on. So I can see what's going on up there. Here we go. Right. So this is roughly where we left things last time. Here's VS Code. And we were sketching out what it might look like via the workspace to talk to our local and our remote ideas. And we're going to put that to one side for now. If we're lucky, if we get enough time, we'll come back and actually continue to work on the init command itself. And we may have to do some tidying up. We may have to. I'm gesturing with my hands. You can't see. We may have to do some tidying up to comment out some of this code temporarily to get everything compiling tonight. Well, if we get that far. But what we want to do over here is we want a new package. We've got our helpers, we've got our hub flow, we've got our workspace, which also holds our Reaper. What we want is the gal. Let me move a bit closer and get myself on the camera. That's really good. And this is the gal. This is our Git abstraction layer. And this is where we're going to put everything. So first of all, I want to make it clear how we initialize all this. So we're going to have an interface, a structure, called gal. So let's set the license up and let's set the copyright up. There we go. And this is package gal. And we're going to create ourselves a structure. It's going to be a type. It's going to be a struct. I don't know what's going in it yet. We'll see. And we're certainly going to be sticking lots of functions on this structure. I'm not going to worry too much about trying to extract an interface from that tonight. We'll deal with that. We'll deal with that another time because, how can I put this? At the minute, this is a dumping ground. Anything we're going to use to talk to Git is ultimately going to go through here. And what we need to do is focus on initializing it. That's what we need to do. So we need somewhere to do that. So function funct. We want to take a new function. That's what we want to do. Come on. Right. And what is this function going to do? Now, when I'm designing a piece of code, what I'll do first is sketch out what it's got to do as a set of comments. Something I was taught back in the 90s, and it's a technique that serves me well. So the first comment to do is actually to set the scene and say what it's going to do. And yes, I talk about creating an instance even though we're not object oriented. So what do we need to do? We need to find that is a good question. What I'm thinking of here is what parameters do we want? So when we create our Git abstraction layer. That's what I'm thinking of. What do we want to do with that? Because I'll explain and I'll demonstrate rather. So do we have? So the first step is step one. Do we have Git installed in the path? Step 2. What version of Git do we have? Now, here's the crunch part. Step 3. Which backend do we use to support it? This is why the signature for this function is wrong. I mean, this is creating a Git abstraction. This is initializing a Git abstraction layer. But we know that we want the ability to inject a fake Git. We may even want the ability to inject Git from a library rather than wrap around the command line. And so as a result, this can't be the primary way to initialize the Git abstraction layer. It can't be. That's not possible. We're going to have to come up with a different structure. So the first thing we want to do is I'm pointing at the screen, you can't see. This bit of information here, do we have Git installed in the path and what version do we have? These need moving into their own functions. So we're going to have find git.go and we're going to call it which git, because which is the traditional name for this tool. Right then, package gal func which git. I'm not sure what it's going to return yet, but we're going to start using Scriptish for this. Now, I didn't live stream last week. I was going to switch cameras there for a moment. Instead, what I did was shared a video I recorded some months ago before I started live streaming about Scriptish, the library I've built to make wrapping command line tools a lot easier. This tool, in fact, let's go open it up. Nope. Come on. Go scriptish. That's interesting. I've never heard of GoCenter.io myself. Come on. Here we go. Yeah. Right. This library here, which allows us to wrap a lot of things. And one of the things that we can do is it can find things for us in the path. In fact, the example may even do that. Let's go into the examples and have a look. Do we do that? So we've got a simple function here called find get binary. And it returns the path. Or an error if something goes wrong. And that's where we're going to start. We're going to take that example code and we're going to put it into our own function. That's what we're going to do. So we might as well just grab all of that and shove it in here. And then we need some imports. And we can just go cut and paste that for speed. There we go. So we now have a function called which get. On success, it will return the path to the current Git binary. And on failure, it will return an error of some kind. I can't remember what error it returns. That's something we'll have to look into. But that allows us to find our Git find Git. It returns current Git, such as the path. All right, such as your path. What does it do on success? On success, returns to the Git binary. Failure, it returns an error. And we don't, we've got to run this to find, and we're going to take this apart to find out what error it comes back with. I can't remember which returns off the top of my head. And I don't seem to have, yes, we don't seem to have IntelliSense in here, so it's not telling us. So we'll go look that up in a bit. Well, that's okay. Now, this tells us if we've got a binary called Git. It doesn't prove that what we've got is Git. And that's an issue. So what we need to do is we need to figure out a way to run Git to prove that it is Git, the source control management system, and not something else that's got the same name. It almost certainly won't have, it's very rare for something else to have the same name, but you never know. So let's have a look at all the commands it's got. Is there anything in here we can call that's going to give us proof? It's proof we're after. And we've also got to make sure that whatever we do is likely to work with every version of Git out there as well. So I'm just scrolling down. Is there anything I feel confident about? I'm not sure there is, to be honest. A lot of the subcommands that are Git specific probably aren't going to work, aren't going to give us a reliable output if we don't have a Git, if we're not inside a Git repo at the time. That's the thing to be careful of. So I might just go with, I see, I mean, even the output of Git version, it's just, it's so plain and so unreliable. I think we may have to park that one and come back to it another time. Actually proving the binary we've found is Git and not something else. That might be the more practical approach tonight. So we can find Git. That's good. And the next thing we want here is to get which version of Git we've got. License, package gal. So func Git version. Right. The reason I'm hesitating is it's time to organize things a bit more. So I'm going to have a, not raw is the wrong word. I want a sub package for those commands that aren't technically part of the gal, where we're just calling Git directly. I'm just trying to decide what to call it. I'm going to go with raw for the moment. To hell with it. So we're going to stick you in there. Yes, please move. And we're going to move Git version into here as well. And you are package raw. You are also package raw. The idea is these are commands. Why are you complaining? Expected string found. There we go. That's might explain why IntelliSense wasn't working as well, by the way. Nope. Go to definition, no definition found. Not having any luck there. That's a shame. Anyway, so Git version. We're going to import scriptish Git version, and we want the path. So Git path is a string, and we're going to return a string. So what we're going to do is we're going to run a pipeline. We're going to build and run a pipeline. So we are going to exec, and let me jump over here. So this is me jumping into scriptish to remind myself how it works. Here we go. Perfect. So we're going to run an exec. We're then going to search the output ourselves. Exec. So we want git path. We want minus version. The output of scriptish.exec goes into our pipeline. This is a source, if you've watched the scriptish video. And we now want to do a filter on it. And what filter do we want? We've got git version something or other. Now very quickly, oh hi Rob, I'm sorry I didn't see your messages. Welcome aboard, good to see you. Now then, what I'm doing here is on my Mac, which you can't see. I'm just going to run a terminal because Apple's Git has a different output for the version command, if memory serve. I just want to see what that looks like, and I'm sorry you can't see it. Come on. Right. So scriptish dot grep. So this is a filter, and what we want, let me just get it right over here. It just takes one parameter, which is the search string. So for over here we want git version, then we want the rest of that returned back. That's what we want. And you want a comma there to keep you happy. There you go. Right. And you are complaining because we can return an error as well. So let's do that. And then you're complaining because we don't have that. Git version. No, executes the given git binary and returns its version string. Right. So that's cool. So let's test this. See if I can remember how to do this. Well, when I was writing Scriptish, I used VS Code to do it. And my memory of it was very straightforward to create and run unit tests for individual functions when I was building Scriptish. I remember it saving me a lot of time. And let's see if I can remember how to do that. This is where we might need to start commenting out other code we've written previously so that we can get this working. And to help with this, what I'm going to do is actually open Scriptish itself. I've got to cancel, file, give me a new window, and then let's open Scriptish in here. There we go. So, update all the tools again. This really is proving to be a bit of a pain. The trick is to only have one version of Go installed on your entire system. I suspect. Something I really should sort out. So, if we look at this is the Scriptish code we've got open now. This is one of the functions. chmod changes the permissions on a file. And it has an associated test file where we actually run a test and tidy up after ourselves. Actually, it's run several tests. 2, 3, 4 tests. And what we want to do, we want to bring this level of testing to everything we're building. That's what we want to do. So we are going to do exactly that. So if I go over here, we need to test which Git first. So we're going to go which Git test.go. Set up the licenses. These snippets are so handy. Package raw. And do we need to import Scriptish? We probably don't. Don't need to import Scriptish. So the next thing we do, this is handy. An Assert Library. So I'm going to go and grab that and import it. And it doesn't have an alias, so that's good. We also need to import the testing library, testing module, sorry. And what we do here is I'm just grabbing this, just giving our pattern, and then the name of our test explains what to do. And it finds an installed Git binary. Now then, let me set up my 3 stages of testing. It's time this went into my local snippets file. So bear with me, I'm just going to grab these and I'll walk you through it. I was doing something very similar on Friday in the day job with a developer, but not in Golang, in a different programming language. Right, snippets. Let's grab that. No files I want, it's this. Configure user snippets. Snippets. Snippets are awesome. You really should be using snippets whenever you come across a repetitive pattern to save you an absolute ton of time. I'm going to call it steps, not stages. They're just little, I mean, they're not macros, they're just like little templates that you stick in order to save an absolute ton of time in typing. So whenever you come across a pattern, put these in place. Do it there and then, like I'm doing now. Now this is my live streaming account on this laptop, so this is why I don't have it set up here, but I do have it set up everywhere else. Right. So what happens now these are saved? In theory, if I delete these, am I going to regret deleting these? Let's find out. Is I can tab into where I want. I start typing test. If I type and it should pick that up. Test steps. Why hasn't it picked that up yet? Come on, why have you not picked that up? JavaScript, because I made a typo. There we go. Now we've got the right list of scopes. We can type test steps. You see how it prompts me. I hit return because it's the only one there, and automatically I've got my three-stage approach to testing in place. Now let's talk about testing very simply. This is something I need to make several long videos on. But broadly speaking, there are 2 ways to do science. There's theoretical science, there's experimental science. This is experimental science. We set up our test, we create a hypothesis, we actually exercise the unit under test, we run some code to get a result back, and we examine the result to see whether our hypothesis is true or false. And that's my real 30-second introduction to how to write tests well. It doesn't need to be more complicated than that. In fact, tests that don't fall into this pattern, in my experience, tend to be more expensive to maintain, more fragile, and harder for other people to pick up and maintain in the future. So, what do we need to do? I'm not sure what we need to do to set up the test. We probably need to manipulate the path. So I'll make a note there. To perform the test, we will do actual result, actual error equals which Git. Now, this is the tricky thing about systems programming. How do we make it so this unit test passes on every machine there is? How do we do that? Git is installed in one place on my machine. On your machine, it may be installed in a different place. In fact, I've got 2 copies of Git on this machine, so that's an issue. On Windows, it's going to be installed somewhere else. On Mac, it may be installed somewhere else. Let me just quickly check on Mac. I've still got that terminal open. So on Mac, it's installed in user bin Git by default. On Linux, by default, it's installed in user bin Git by default. But where did I put this? I built one. I actually downloaded and built Git. And there should actually be a Git binary in here. It may not actually be called Git. It may have been actually given a different name. Can't remember. Scroll up far enough. No, it is just called Git. So you can see it's got a different version to the one that Ubuntu ships. And we compiled this back on the 5th of October. That's nearly a month ago. This is probably out of date by now. So we've got this issue here. Let's go back to where we were. We've got this issue of how do we actually make this test sane and reliable? And I'm not sure I've got an answer. I'll be honest with you. I'm not sure at all we've got an answer. So for today, what I'm going to do is bodge it. Now, how does this Assert Library work? So the actual result was there. We exec the pipeline. So we don't need a let. Too much JavaScript. And then we call assert. There we go. So assert.null. We make sure there's no error. And then we call assert.equal. And it takes t is the first parameter, our testing structure, which is passed into us by the test harness. And then we've got expected and actual by the looks of it. Let me scroll up somewhere else and double check that structure. Yes, expected and actual. So we'd do expected result and actual result is what we would do. It would help if I actually did that right. There we go. Now to run this, let's have a look. Go test file. Let's try that. It passed. Look at that. My test case passed. That seems too easy. Why? What seems far too easy? I want to see it fail. So what I've done now is I've updated the expected result to be an invalid value, and then we retest the file, and it failed. It did fail. Awesome. Okay. Wow, that's really easy. Now what we want to do is we want to write some testing around the error. That's what we want to do. So the first thing we're going to do here is we're going to nuke the path. Now then, how do we do this? Set environment variable. I remember this being a pain, setting the environment variable in Go. I could be wrong. Yeah, it's not. So we're going to import the OS package. Apologies if I'm whizzing through this a bit. Now we need to back up our let's do this right. Backup path, and then we want here old path as a string. Again, my syntax is probably off. We'll deal with that in a moment. So old path equals os dot get env path, and then func restore path. I'll show you why these are actually, we don't need these as exported, so we can put them lowercase. I'll explain why these are separate functions in a moment. And os dot set env path old path. So what we're going to do up here is we're going to back up the path, then we're going to do os dot set env path empty string, so that we get an error. At this point, our function whichGet cannot succeed. It cannot succeed because the path is empty. That's the idea. And we want to assert not nil, nil, actual error, assert dot error, actual error. So we get an error back. Now then, give me a moment. I just need to remember how to declare variables at the file level. Declare variable at file, outside function, that'll do. Right, so it's a var, and you're unhappy why? You expect a semicolon. Let's initialize it. Nope, you don't like that. Expected semicolon. So I don't get to say its type? I don't believe that. Does the type go first? var old path, double quotes, There we go. Success. Now, no, you're still not happy. Now, the point is I want to use defer to make sure we restore the path regardless of what happens inside this test. Because we need the path to work for other things. And it's a trick I've used up here. Aha. We just do it that way. Defer restore path. There we go. And now why you're actual result declared but not used. So I'm going to assign that to the empty hold placeholder. There we go. Now let me explain what I've done here, because this is a bit buzzy tonight. It's a bit all over the place. For this second test to work, to make sure that wget returns an error, we need to make sure that it cannot find a Git binary. The most foolproof way to do that is to make sure our path is empty. If the path is empty, this unit test should work all the time. I agree and accept there may be circumstances where it doesn't work, but for the environments I'm going to run these unit tests in for now, we should be fine. Problem is, path is an environment variable. It belongs to the process that is running. It doesn't belong to this function. It doesn't belong to this particular unit test. As a result, we need to make sure that we restore path to its previous value. If we don't do that, then future tests may break. And we don't want to rely on the order that tests run in either. So we have to actually put the path back to what it was. And Golang has a fantastic way of doing this with the defer statement. And what defer will do is say, when this function exits, immediately before you exit, run this particular function. And that's why backup path and restore path I've made those little functions rather than just trying to do it within this within this particular test function. Because it doesn't matter what happens, restore back path is guaranteed to be called. My understanding is the only way restore path won't get called is if the whole binary exits, at which point it doesn't matter because the binary is gone. So that should do. Now, does it run? Let's find out. It runs. Look at that. So it's compiled and run it. We get an error. Now we really should test what kind of error comes back. And to find that out, I'm going to go into here, into Golang, and go, it's going to be a built-in, actually I don't need to do that, I can just do which. Right then, I'm going to answer your question in a moment, Rob. So if we look at which go, let's have a look. We return something called status not okay, which is a status code, which I'm not checking for because I'm not using them at the minute. I'm just using an error comes from lookup path. And lookup path comes from Golang's built-in library, OS Exec. So what does it return? What does look like? Now the way to find out with that, I showed you this trick a couple of weeks ago, but if you didn't see it, let me show you again. If you go into Golang's package documentation, golang.org, pkg for package, and then the package name, when you scroll down to the actual function you're after, And I'm not seeing the function here. Am I looking in the wrong place? Import, exec, yeah, lookup path. It's not in this file. What have I done wrong? Golang lookup path. Yeah, you're saying it's in here. There it is, right at the very top. Right, so we've gone to this here. Now, we found our function in the Golang official documentation. If you click on the function name, it takes you to the source code. Isn't this bloody marvelous? While it might not make sense in certain other languages, I wish every language did something like this. While there's an argument, if you need to read the source code, the documentation is not good enough. This is brilliant. Being able to dive in and see for myself what it actually does is just brilliant. So it calls something called find executable. And then it does a search of the path. So find executable is going to be right above it. And the error we get back should be, I mean, there's an error not found declared. But reading this code, I'm not convinced it actually returns that reliably. Ah, yes, it does. Error, file, error not found. Yes, it does. So it returns an error not found. So we're going to write a test for that. And the reason we're writing a test for that equal error. Let's have a look at this. The error, so that should be exec.not found actual error. Your documentation, so your tests are an opportunity to document what your code does and how it behaves. So that's what I'm doing here. Now I can't remember. Right, I need to look up this library to see how you test errors because I can't remember how you do that. Did I do this in here? Let's have a quick search. Try to see if I've already done this in Scriptish. What have we done? Doesn't look like in Scriptish I've actually been testing for the kind of error that's come back. Just going to double check and see. So sometimes sometimes Golang packages will actually provide functions that you can pass an error to tell you whether or not you've got the error you're expecting. So let's actually have a quick look and see, does it provide one of those? Sadly not. Sadly not. So let's not mess about. let's go look at our assert package we're using, and let's see how we test for errors. Go and its import statements. All right, docs, assert package. Yeah, I want give me some documentation on errors. And we don't want to use marks. I want to see all your assertions. We can create test suites. That's something we may play about with as the app grows. It's not something I really needed for Scriptish. Wow, this hasn't been updated for a while. 18th of August, a few months. Right then. Let's have a look. Search and compare. Ooh, we can read its test to see how it does it. Yeah, don't write unit tests like this. While they are efficient, they're not effective. Not helpful. So, oh, errors.go, silly me. Try looking in there. Nope. I was getting my hopes up too much. .go. This is something I don't do enough with. I need to do more with that. I don't actually generate my own Golang docs, and there's a good argument that I should do. Right, assertions.go. Do we have what we want in here? Error assertion function. So it's a type. Test objects are equal. It's cool looking through code like this, finding things. But we're in a hurry, so we will go with error. What was I using? I was using equal error. So let's use that. Panics. So you can actually do a panic and recover from it. So expected error string. Okay, so I've got to pass a string in. So how am I going to find out what that string should be? I am going to do this. I'm going to call the error method on the error, and it should return a string, which should satisfy everything. Fingers crossed. Let's run it and find out. And then I will stop ignoring Rob and actually answer some of his questions. Sorry, Rob. There we go. Expected. Now, interesting thing about this is this actually proves that the parameters for this particular function are the wrong way around. It's actual then expected. So this should be actual error, and then the expected goes afterwards. Now then, for readability, expected, we stick it up here. Executable file not found in $path. We stick it up here. Expected error. I'm going to rename that. Call it expected error message. I really do need to set all these tools up. Right. Now this is also interesting. I've just saved the file. And it looks like it may have just tried to run the tests again. I'm not 100% certain. Let's just do this. Right, so that's now running anyway. So even though you could put the string you're after down here in your when you're testing the results, remember we are creating a science experiment. We're establishing our hypothesis up front, and as part of that, from a readability point of view, it helps if you actually put what you're expecting into variables up front, rather than just embed them as static strings down here. And on that score, something we can do, assert dot, do we get we get a not empty? Do we get an empty? We do. We get an assert dot empty. That may not work. Oh, it doesn't return an error. That's good. As part of that, we've set the path to blank. We should actually run an assert afterwards to prove that our test conditions have been met. Our setup has worked. And if we run this again, still passes. That's good. Right, let's go and stop ignoring Rob. Hi Rob, good to see you as always. And let's look at some of the comments he's been leaving while I've been coding. Right, so the first one, let's bring this up, is Rob has said that Git is installed and use the local bin Git for him. Now what does that mean? It has a consequence. If I was to commit this code and Rob was to try and run these unit tests on his machine, these unit tests would fail. It wouldn't work. So there's an issue there to come back and revisit. How do we make this reliable? Right now I don't know. I'll be perfectly honest. This is the kind of thing where people often use mocks or inject mocked results, which unfortunately Scriptish today doesn't support. So it might be I've got to extend Scriptish to make that work. We'll have to see. We'll have to see. Slightly earlier on, when I was writing the version code, which is over here, Rob asked a question about the grep. And Rob asked, does the grep return what's in the bracket, just what's in the brackets? And what he's referring to is this here, which in let me see if I can get this right. In regex terms, that's called a grouping, if memory serves. If I'm wrong, leave me a comment below. I hope so is the answer. I hope that's what it returns. We'd have to, again, we'll write a test in a minute and we'll prove it one way or the other. But that's what, fingers crossed, that's what it should do. And Rob's just confirmed that he thinks it's called a grouping as well. So we'll prove this. We'll prove we'll prove what it returns when we write the unit test in a moment. This is another reason why we're going to write unit tests as we're going along. Is the last thing we want to do is get pretty deep into functions and structures that depend on these functions, and then find out these functions aren't behaving as expected. So we do something, we verify it, we move on. That's what we're going to do as a cycle. Rob also was celebrating something, but it was so long ago. It might be me showing unit tests, I don't know. But it was so long ago now, I can't remember what it was. In fact, I didn't even notice it. I had my head down coding. So whatever it was, thank you. Right. And then Rob's asking, Rob remembers what it was. It was the fact that the tests were passing. That's what he was celebrating. Awesome, thank you. And then Rob asks about multi-threaded, multi-process tests. And I presume that's in relation to messing about with the path. It feels about that kind of time. Now, the honest truth is, I don't know. Now let me break that down a bit more. Assuming I'm right and that Rob was asking about whether the environment is per setting and restoring that was per process or not. As far as I know, when the Git test when the Golang test harness runs, there's only one process as far as the kernel is concerned. Classical execution environment, as far as I know. I don't even know if you can run multi-threaded tests in Go. I don't. It's a very long time since I've done that in anger. I can't answer that question with any sort of confidence. Taking a step back and speaking more generally, threads are not processes. Threads share a common context, which is the process. If you change the environment in one thread, does it change the environment for all other threads? I am not certain. However, let's go and see if we can find an answer to that. So, for sake of readability, I'm just going to remove Rob's comment from the screen. Right. So we're going to do a search and see if we can find an answer together, because it's an interesting question. Now, when you are doing this search, it's important to remember that you're looking for this in something like C or a compiled language like Golang. It doesn't matter what Python does, because Python could have its own mechanism that's emulating an environment. Java has a runtime environment, the JVM. So it too could be adding a degree of emulation to how environments work. So any results about any language that has a runtime part of it, and PHP is the same, although PHP isn't multi-threaded, thankfully, you can't just go and jump on those results. So the fact that we have correct trackpad. I was using the trackpad for the Mac there. So the fact that Google's returned something that happens in Python as the top result is absolutely bloody useless. Don't bother with it. So, excuse me. What we're looking for is something that's more C-based. Of course, C being a single character probably doesn't bring up any useful results. We could look at C++. It's unlike C++ is unlikely to be doing anything with that. I've got multi-threading in C. It's alright. Email messages, nothing interesting. Does this have anything useful? Doesn't talk about the environment. So this is talking about p-threads. Let's have a look. Right then. So Rob has just said, in his time it was probably like minutes ago with the way YouTube lags. Rob has just said that he guesses that in fork and exec, the child starts with that parent's environment. I used to know all of this. I want to say yes, but I have a memory that you can mess about with that. But we'll find that out in a moment. So POSIX 1 requires that thread shares a range of other attributes. These attributes are process-wide rather than thread per thread. Process ID, parent process ID, process group ID and session ID, blah, 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 current directory. Doesn't say anything about environment. Huh. Doesn't say anything about environment. Yes, so the man page for pthreads doesn't say whether or not the environment is per thread or not. Fancy that. So I'm just having a look to see here. That seems like a bit of a gap, really. Right, let's see if there's anything around env. Right. So the reason I searched for env is I noticed there was this long list of C functions. So all functions specified shall be thread safe except for the following functions. Well, that's not the most helpful. So put env, get env, set env are all non-thread safe. Yeah. Doesn't tell us. Now, something else we can do is actually see if I've got a local man page that is any more useful. And of course it isn't. Right. So unfortunately we don't know. But what we can do is come out of this, Q for quit. Let's have a look at the man page for fork. I know this is totally a Tony tangent. This is totally going down the rabbit hole here. But yeah, these kind of things interest me. I used to know a lot of this stuff. I used to do this kind of programming in a different life. So I'm just looking at fork. Right then. A child process is created. So fork creates a child process without and you inherit the you inherit the environment. That's for sure. Because what you do when you run fork is you duplicate the calling process. So you inherit all of this. Right. Okay. Right, now if we jump to exec, I have a memory. Yes, I was right. There are four. The thing with exec is there isn't just one exec function. There's a whole bunch of them, and they allow you to manipulate things in different ways. And some of them allow you to pass in a new environment. Which is why I was hesitating earlier. Some of them take as their parameter the ability to replace the environment. See, fork creates a child process and carries on running exactly where you called fork. And if memory serves, you look at the return value from fork to work out if you're parent or child. And it's known as the fork exec cycle because the child, once the code realizes it's running in the child, not the parent, it then calls exec to replace the process, the current running binary, with another binary. Keeps the same process ID if memory serves. And as part of calling exec, you can actually say, right, here's a whole new environment to run. So, I mean, we'd have to build a C program and do some testing to absolutely verify things because the documentation has gaps. Well, the documentation I'm looking at has gaps. My guess is with a thread, you change the environment variable in one thread, it changes it for all threads. That's my guess. And of course, that may be operating system specific, but that's from what we've just looked at, that's what I'd go with. And Rob's just spotted something else that's interesting. So let me just jump back to here, just because it's a bit tidier. And Rob says that there's a parallel flag that we can pass to go test. So we can actually run our tests instead of linear, one test after the next. We can use more of the machine's resources to speed up the running of the tests. I'm not planning on doing that, but it's always nice to know that these things are there. I might do that when we get round to running these via CI on GitHub Actions. And if we get the code compiling before we quit tonight, maybe next week we could do GitHub Actions. Something to think about. Anyway, for now, we have a test that's a little bit fragile because it only works on my machine. And I haven't got an answer for that yet. But for now, we've got the ability to run some tests. So what we now need to do is move on to testing our Git version function. And to answer Rob's question about whether or not the grouping is what's returned from the grep. I'm relatively confident it is, and I'm pretty certain Scriptish has some tests to prove it either way. But I'm not going to cheat. I'm not going to run the tests. I'm not going to look at the Scriptish tests. What I'm going to do is write my own test for this because we need to prove it works here. And this is another important principle. Yes, I could look inside Scriptish to see what it does. I mean, it's my library for God's sake. Even if it was closed source, I could still do it. But it doesn't matter. We are integrating with it. We are calling Scriptish to do work here in the Gitflow extension. So it's the responsibility of the Gitflow extension to prove that the behavior is what you expect. You can't just rely on the documented behavior. You've got to prove it, because that behavior could change in the future. And if you haven't got a test that's watching out for those changes, you're going to ship broken code. So you've got to do this. You've absolutely got to do this. Right, so I'm just going to go up here. I'm going to grab this for speed. Go over here. I'm not sure I need OS. So we're going to do func. And we take testing.t, isn't it? Is that right? It is. We take testing.t. That's good. We have our test pattern. Right. I'm going to start here with actual result, actual error, git version, and it needs a string. So what we're going to do is so our test is going to be, we need a git path, so git path, which git path error, and then we're going to assert so this allows us to find out where Git is installed and make sure that we haven't returned an error. So we can pass Git path into there. Now then, what are we expecting? That's tricky. Again, this is Git version specific. It's specific to what's in the local machine. So I'm just going to chuck something in there. We're going to prove that the actual error is nil. So remember, it takes t first and then actual error. And then assert equal. We want t. It says expected here. So we want expected result. And then we want actual result. Actual result. Come on. There we go. Right, let's do that. So that's compiles. Right, so let's run this and see what happens. This is going to fail because I'm pretty certain it's like 25 point something. There we go. It's expected actual. Let's return the whole string. Let's return the whole string. So my understanding of how my grep works is wrong. There's no two ways about that. So now I'm going to go and look at what it does. And grep is a filter. So let's go have a read of it. So grep doesn't extract content from a line, it extracts the whole line in that respect. So I was thinking of grep as I use it in my day job in normal languages, but in this context, grep filters by line. So a line is either in the output or out of the output. That's the difference. At which point, so all this does here is prove that that works. And now what we need to do is we need to find a filter to extract the version from there. So let me jump back to my documentation for Scriptish. And there's a table of contents in here. Filters, 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 filters. It's possible I need to extend Scriptish at this point. I may well need to extend Scriptish to give me a filter. Yeah. I think we may have to extend Scriptish. I'm just looking through this, and none of the existing functions in Scriptish allow me to extract part of a file, part of a line like this. Doesn't allow me to do it. And we've got trim suffix, which allows me to remove the end of a string. So we could have a trim prefix that takes things away off the start of it. We've got plenty of translation support. Tail. Yeah, Scriptish needs extending. There's no two ways about that. Good old Scriptish can't actually do what I need. Fancy that. All these tests. This thing's got full test coverage, or it did have when I originally built it. And I can't actually do what I want with it. Rob's saying that trim doesn't help due to the Apple Git version string. Yes, but what you can do, Rob, is you can trim the string Git version from the front and just return the whole remainder of it as a version, and then parse that separately. You can break it down into two operations. What I'm looking for, cut fields. Hang on. We've got a cut fields function, which isn't guaranteed to be accurate. So we can do this. What parameters does it want? Right, and here's a spec. Why are you unhappy? Because you want a trading comma. Really, you want cut? Well, I've got cut, but I'm hesitating because the lack of the grep guarantees that Git version is there. Let me think this through. Problem is, I'm using a powerful programming language, but when using Scriptish, you've got to think more in terms of shell scripts, just with strong types. So by running git version minus version, we get our string. The grep guarantees that we've got a line that says git starts with git version, and then cut fields. We'll say, right, just give me fields 3 onwards. So it will cut out git and it will cut out version because of the white space there. That's what it will do, and that's how you do it in a shell script. So now if I run the test not found because I'm in the wrong file. Let's try that again. I want more than the third column, Rob. Rob's saying I want the third column. The thing is, I want everything after the words git version. Because if we're on Apple and Apple's patched it or Microsoft's patched it, I want those patch numbers. They may matter. When we did a walkthrough 5 weeks ago, when we did a review of the existing code, I'm pretty certain we came across a piece of code that actually checked for whether you're on Apple or not, and it did something differently. So I need the whole thing in order to parse it separately. So this works. This works. So now we've got initial piece of code that proves that git version works. It returns everything from version 3 onwards. Now, again, we've got because we're doing systems programming, we've got an interesting problem here. Is all these different Git version strings and their different structure. I need them all in order to prove that Git version is working reliably. At the minute, these unit tests only prove that the raw commands I've written tonight work on my machine today. When Ubuntu releases a new version of Git, when they update their Git package, these will stop working. And on macOS, these aren't going to prove that I'm getting the information I need. So as unit tests go, at best they're placeholders. And I need to figure out a way to solve that problem. But I don't think I'm going to solve it tonight. I think solving it tonight is a distraction. And we've had enough of those already. Digging into threads and environments. And I want to crack on. So for now, I'm just going to close these. Because I really want to get the gal bootstrapped. And the whole point of these functions is to help us bootstrap the gal. So if we jump over here, I've got to share that, Rob. Oh dear. So Rob, for those who are listening rather than watching, Rob's just done hashtag sorry not sorry. Oh dear. Oh dear. Oh. I will stop laughing in a minute, I promise. Right then. Back to this, back to initiating. So what we're trying to do first of all is figure out which Git backend we want to run. So I'm going to restructure this, but this is just to get us going for now. So we want Git path equals which Git. And we need to import which Git. We must do that. In fact, we've even got a package statement here. So this is package gal, and we want to import github.com Gambaro digital. I'm pretty certain that's wrong. Give me a moment. Where have I been importing things? Hubflow. I think I've imported one in there. Oh, I have done that. Right. This is almost certainly wrong because we're actually still in the datasif space. So these imports work locally. They probably don't work reliably anywhere else. So there's quite a lot of tidying up to do. Gal raw. Raw.which Git. Git path. Comment assign that. If air not equals nil, I don't know, do something. Probably we probably want to do it from OS. And why are you complaining there? Because you don't need that. And you are complaining because git path declared but not used. Okay. So we do git version. We have to assign it first. Actually, let's just. I think this will error because I'm reusing error, so I don't know if I can get away with that. And not equals nil. Do something. So there's another to do. I've got to come back to. So I need a die function. And hopefully you're complaining that version is declared but not used. That's okay. Right. So we're gonna restructure this slightly. So this isn't new or init. This is, so find backend. Find backend. We'll just call it find backend for now. Normally I'm very good at naming things, but what you're seeing is the very first version of this structure of this code. Normally by the time I've shipped code to people, you're on iteration 10, 15 plus. So you're seeing it right at the very first, and I haven't yet managed to iterate over all of this very much. So now we've got a version, and that version string is going to look something like, that, or where's my terminal gone? Over here. It will look something like this. On Windows, it may have its own structure as well. I don't have Windows booted to have a look, and I'm not going to do that tonight. So the question is how do we then use these version strings to create sensible backends? Now the obvious answer is we need, so we're going to have all these backends. We're going to put the backends in one package, but each backend we're going to have a fallback. We're just going to call default for now. This is where I should probably be drawing a package, a diagram to explain what I'm up to. And this is actually going to be our gal itself is actually an interface. Yes. Gal.go isn't a structure. It's an interface. And backends like default actually implement that interface. That's what we're going to do. So this is type default get backend, and it probably has the git path in it. It's probably what we want. Minimal supported git commands, something like that. And now in this file I'm going to put in all the different functions for the gal, and the gal itself becomes an interface. And so we're going to have version returns a string, for example. So I'm just bear with me with this. Hopefully it will become more obvious as we go. And we're going to call this, we're going to pass a pointer, version returns a string, and this is literally, we're going to use scriptish again. And actually what we're going to do here, actually we're not going to use scriptish for this, bear with me, I've got a better idea. We are going to import .com digital Gitflow. I should probably put these as the proper data sift strings. I should probably move that package, but that's for something for another day. Gitflow package gal raw. Okay, so retval raw dot git version g dot git path. So we're reusing our raw command. There's no point in duplicating code if we didn't need to. Errors and null. I could do something horrible here. I could do this. I could literally, what I've just done here, I've reused our existing raw command of git version. I think we're going to build a library of these. And then what I've done is I've assumed it will never return an error that I'm interested in, so I'm just returning the return value. Pulling a face there. That is both pragmatic and horrible simultaneously. In theory, because we already validated that, we'll have already validated the git path by the time the structure is built. So in theory, it's always safe and will never fail. Therefore, there will never be an error. However, if the machine is starved of resources and can't fork exec, there will be an error. Bugger all we can do about it. And I don't think it makes sense to pass the error back, but it will exist. Rob's just gone, never fail in bracket, in quotes. That's what Rob's just said. And the thing is, it can fail. If it fails, it's because the machine it's running on is screwed in some way or other. But don't forget, we're calling an external binary. That binary can change. It can be updated while we are running. There is a theoretical risk of that. So what do we do in that point? We need to do something about that. Rob's just pointed out that the binary can be removed from under us as we're running. Yep. Or it can be chmodded. Someone could be doing a package update, and actually installing another version of Git while we're running. Especially on these are very low likelihoods because we don't tend to share machines anymore. We tend to all have our own dedicated machines these days, so they're all quite low risk, but they could happen. So we've got to decide what happens if running Git fails. Which means we need to think about whether or not we should funnel all the ways we run Git through a common piece of code so we can centralize our error handling. That's what we need to think about. Exactly, Rob. That's one of the points I'm trying to make. You've made it far more clearer than me. So Rob's just said right up until someone app gets updates in one terminal while working in another. Yep, that kind of thing. So we probably need to funnel this. We probably need to funnel how we're running the binary through a common piece of code, so that errors are handled centrally. Which means running our raw Git version might not actually be the sensible thing to do here. Even though it exists, it might not be the sensible thing to do. We may well be better off doing something else. I'm just trying to decide where that should live, because it's going to be shared by all the Git backends. Now what I need to do, let me just have another look at Scriptish for a minute. What I need to remind myself on with Scriptish is whether I can run a pipeline and then add to it afterwards. If not, I'm definitely going to extend Scriptish to do that. I mean, that might be an impromptu live stream tomorrow night rather than do it tonight. But what I wanted to do, let me sketch out some code and show you what I want to do. Is I want to do something like this. And I'm not saying for a moment this is going to work. It'd be nice if it did first time, but I doubt I've thought that far ahead. So package backends, we definitely want to import Scriptish. And what I want to do is do something like this. Func call git. And I want it to return a Scriptish dot pipeline. So, and we need a git path. So we're going to have pipeline, new pipeline, and I'm just going to switch back to code that's working to remind myself of the syntax. That's fine. And I actually want to grab Git Exec. But instead of minus version, what we want to do is we kind of want to pass in a whole set of parameters here. And I'm trying to remember how we do that. We did this last week, didn't we? Something like that. Hopefully we can do that. Right, so I want the pipeline, and I want to run it first of all. Remember, I'm just sketching this out. I'm not claiming for a minute this is going to work without digging into it a bit. And let me just put a comment here. So runs Git for you, checks for execution errors, and turns the pipeline for you to do your own filtering and capturing extraction on, something like that. So if pipeline dot, come on. Sorry, it has been a while. I need to remind myself what a pipeline can do. It's actually a sequence. Scriptish is well worth digging into. It's got quite a lot of power inside it. Keep track of our steps. We may not actually be able to do this at the moment. I may actually have to extend this. So we get a sequence back, which we wrap as a pipeline. We've got bytes, we've got error, exec. Exec returns a sequence. That's good. We can flush it. Right. In theory, I can do this. Do I really want to return a pointer? Yes, I do. In theory, we can do that so that we could then go on what you're unhappy about. Missing function body. What have I done? Is it because it's on that line? It's because there's a colon, isn't it? Now what you're after? Missing function body again. What have I done wrong syntactically? As mentioned on my last live stream, is if there's one language I struggle to switch in and out of, it's always Go. Other languages, absolutely fine. Do I spread them out that way? So you don't like that, you don't like that, you don't like that. Oh, why can't Go sometimes share syntax that other languages use? It would be nice. Anyway, I'll fix that later. That's the general idea. We want to use the spread operator to pass in our arguments, and if everything's good, it's okay. And if we get here, something went wrong. Now, here's the problem. There's many reasons that things could go wrong running running Git, and not all of them are related to the binary itself. Some of them could be the commands we run return a status code greater than 0, and that's legitimate. So we've got to be careful about how we return the error. So there's some thoughts to be done in that. But the idea is basically if we have all of this, then in our backends, what we actually do is is pipeline equals call git g.get path -- version, and then we want to add some things to the pipeline. Now I'm pretty certain there's a way to run pipelines inside pipelines. I did something with this. Right, calling from another. There we go. We can call one pipeline from another. By making a list. Now, can we do the same with pipelines? I'm trying to remember the difference between pipelines and lists. Let's have a quick look. Here we go. Fortunately, I documented Scriptish really well back a year ago now. Aha, that's the difference. But we should be able. So if we can call list from list, we should be able to call pipelines. Yes, run pipeline from list. Here we go. That's what I want. Reusability. Aha, past me did think about this. Bloody hell am I lucky. It also means... It's alright. I'm making a face a bit because... while we can call the pipeline from a pipeline, I kind of want to extend the pipeline instead. So this isn't quite, Scriptish doesn't quite have the power that I want today. Because I really want to be able to do pipeline dot, I'm making this syntax up. I kind of want to be able to put some more parameters in here afterwards. Actually, this might not be as bad as it looks. This might not be as bad as it looks. because we can do scriptish run pipeline. Now in call git. That's our call git call. So we've got our pipeline. And then we bear in mind pipeline equals pipeline.exec. No. New pipeline, we create a pipeline, exec, and then after that we can do it's not pipeline, it's scriptish. So let's import scriptish into here, because then we'll get some sort of autocomplete. Digital go scriptish. There we go. And has it caught up? No, it hasn't. And let's save it. So this is a capture method what I'm using now. And where's my table of contents? Because it's quicker. Got syncs. So table of contents, table of contents, table of contents, capture methods, trim string. There we go. So trim string returns its standard out, and an error, it returns an error as well. And if something went wrong, we get standard error instead, which is something we may have said I reserve the right to change. If error equals nil, return pipeline. If we get here, Houston, we have a problem. That's the general idea of what I want to do. So we're going to have callgit return a pipeline for us. That's just running our arguments. Nope, that's not what I wanted. Sorry, wrong one. Let's go back to callgit, which is over here. So it builds a pipeline for us. It's got to return the pipeline itself. Yeah, error handling. Now, in other languages, in other walks of life, what I do here is I normally provide an error callback so that the caller can decide what to do about errors. And some of my later PHP work and all my TypeScript work, I have this concept of an on-error callback, which gets passed in. And certainly in TypeScript, it's really powerful what I do with that these days. I don't have any of those sort of concepts in my Go programming at the minute. And I am so tempted to go down that route. I am not going to yet, but I am so tempted to. So tempted to. The alternative is that I extend the design of scriptish so that I can embed error handling, standard error handling in there as a callback, in fact. That's not a bad idea. Something like scriptish.errorf. Check if Git failed to run. Something like that. That looks good. It doesn't exist. I'm glad I wasn't taking a drink there, Rob, when I saw that comment. Rob knows me too well. Rob has been in the audience for some of my talks as I've developed this idea of the on-error callback. I've sort of been working towards this approach. When did I start this? Arguably in 2017, when, at my Edinburgh talk about 5 ways to improve application robustness, is arguably when I started developing this idea. So over 3 years ago now. And Rob has certainly been in the audience when I did rail-oriented programming in Birmingham, where I walked the audience through introducing this kind of structure. Those are good talks. Those are good videos because they're very interactive with the audience. They're both long. I think both videos clocking at well over 2 hours. So if you want to watch both, that's most of a day gone, I'll be honest. But if you've got the time, sit down and go through those videos. I think they're some of my best talks. But I think we can sort of get around this by adding this concept of adding error f, where we pass an error function in to Scriptish. Now I've got to extend Scriptish for this to work, but that is tempting me. That is tempting me a lot, because we really do need to standardize our error handling. And right now that is something that arguably we can't do in Scriptish. And it feels like we should. It feels like we should be able to do this. Let me just move the mouse out of the way. Because alternatively, let's say call Git actually returned a string instead of a pipeline. And then alternatively, what we'd do is we'd do something like this. Let me go with... We need to go with something a bit more complicated than version. I'm just doing this to demonstrate. Rob's just said that the Birmingham meetup where I did the rail-oriented programming was a really hard place to photograph. That's actually a good thing. I mean, kind of. It's not about me, it's about the topic, I'd argue, and I don't like being on camera anyway, as you can tell from these live streams. So imagine something like this. I'm getting ahead of myself here. Again, this is code I'm just sketching out, but an alternative way we would do something like if we weren't going to add error handling to Scriptish, if we went with what it can currently do and treated that as a design constraint, we'd do something like this. Row output error, if error, return double quotes error. Rob said that the Birmingham talk was a good talk and he'd like to see where my thinking has evolved. I will do a talk on my... So where that's gone is the safely typed organization on GitHub with TypeScript. I've gone a deep dive into the power of TypeScript to help me express what that can do. And over Christmas, I'm planning on getting Story Tracker, the tool I built for the requirements. I'm planning on using... I'm going to have most of Christmas off. If we're not in lockdown, I'll be surprised. But we won't be going anywhere anyway. And the tool that I used to generate this file, I'm going to be doing a lot of work on over Christmas. It needs a block of time on it. And as part of that, I'll do some live streams, and I'll actually do something about how I'm doing error handling and things with safely typed. I'll do it then. That's what I'll do. But just sketching this out. So otherwise we would do pipeline scriptish.new pipeline, scriptish.echo. Yes, we have an echo. And we would do raw output, and then we would do .grep anchor for that, .exec .trim, and of course we actually have example code for this, which is in Scriptish, so I don't have to guess. Bear with me. Current branch is something we're going to want as an operation, so we might as well get it accurate now. So here's what we have to do to get a current thing. Cool, you see. See, past me did a better job than current me's doing. Look at that. We want all of that, but we'll just do this for tonight, just as an example. So that's the alternative. Is every time we want to actually call Git, we actually do call Git and see if it returns an error. And if it does, and we have to handle that. We could do it that way. The reason I don't like that is we only want call Git to fail if we can't run the binary itself. If we get an execution error, so we get an error trying to execute the binary rather than Git gives us an error. So while this would work to a point, and we could actually fudge it around and get it working, this doesn't feel right. This one here, let me just this approach here, where call Git is a pipeline with built-in error handling, feels better to me. It feels more in line. I prefer this because we could put other error handling in here. So for example, in here we'd do run pipeline call Git g dot git path status, and if anything goes wrong, everything's in wrong place. This feels better to me. Now I may not actually be explaining and demonstrating that properly, but that feels like how I want to go. That feels like how I want to go. Right. I'm going to call it there. We've been live streaming for 2 hours 15 minutes-ish. Actually 2 hours 8 minutes, so just over 2 hours. And I'm going to call it there for now. Let's go back to MeCam. So I think we've made good progress. We've been working on getting the Git Abstraction Layer bootstrapped. We've got some unit tests up and running, and we're digging into some interesting problems around working out which backend we want to load and how the backend itself is going to work. So while we haven't, let me go back to the slides. And where's Keynote? There we go. So objective 1 of bootstrapping the Git Abstraction Layer. I think we've made progress on that. I'm feeling okay with that. We haven't integrated it into the workspaces, and we haven't integrated it into the repos, but that's okay. Until the Git Abstraction Layer finishes initializing, we can't integrate it. And I've already in my mind, I already know how we're going to do that. The workspaces and the repos are going to take the Git Abstraction Layer interface as a pointer, and then they're just going to call it when they need to do work. So that's a relatively small piece of work. And because, go back to Linux Cam, because I know I want this to be an interface, I'm feeling good about how it's going to integrate into workspaces and repos. It's going to be a mother of an interface. It's not going to be pretty, not at first anyway. But I'm okay with that in this particular instance. So yeah, that's where we are today. Back to Keynote Cam. So what do you think? If you're watching this on catch up, please leave a comment. Let me know if you've enjoyed it. Let me know what you think about what we're sketching out, what you think about the code architecture I'm pursuing, whether it works for you, whether you think there's a much better way to do it. Be very interested to have your feedback. Thank you to Rob for all his comments on the live stream. It's a pleasure as always, sir. And yeah, I think I'm going to leave it there. So thank you all very much. And I will see you same time next week, where we're going to pick this work up right where we left off. Oh, and there will be a bonus stream on extending Scriptish to do error handling. And I think that will be tomorrow. I'm not certain, but it's going to be an impromptu live stream at some point this week where I extend Scriptish. Might be tomorrow night, might be Thursday night, we'll see. Thank you very much.